Hi and welcome back to my channel. So this episode is just to provide a first impression mini review of my new Siglent SDG 1032X, which is an arbitrary waveform generator that I bought from a company based in Europe called Batronix. So this is going to be a very quick review, initial impression of this unit, which I think is great, and also of the company actually that I bought it from. So the company, as I said, is called, let me see, I have the, yeah, it's called Batronix. It's based in Germany and they sell products basically from Rohde & Schwarz, Regal and Siglent. And so my opinion about this company is really excellent. And this is not just because I received the unit and everything works, but in fact because things didn't work properly at the beginning. Originally I wanted to buy this unit, the Regal SDG1032X AWG. This is an entry-level arbitrary waveform generator that costs less than the Siglent. It has just one channel and it only gets to 10 megahertz, but still it was this was probably enough for my needs. Anyway, I bought this originally and they shipped it very quickly and reached to me, but it had a problem with the USB port at the back, so I could not recognize USB pens and connect to them properly. So I sent it back to Batronix and they very quickly sent me another unit, still of the Regal SDG1032X, but also this unit was faulty. So it had a dead pixel in the middle of the screen, but most importantly the unit was how to say, it was not very stable. It was shaking a little bit, okay? So it was not nice. And the fact is that this unit, as you can see, one of the reasons I chose it was because it doesn't have any fan, so it's very quiet. But to be fanless, it has this weird and kind of futuristic, I don't know, case. And in my case, at least the second unit that I received, this was completely crap, just to express an honest opinion. So yeah, after this second attempt, I didn't want anymore this type of unit, and I decided to change and to get this Siglent. This Siglent, as you can see, is more expensive, but at the same time it has two channels and it reaches up to 30 megahertz, so it's an overall better unit and I'm super happy about it. Anyway, Batronix sent me this unit, so this was the third delivery, and it actually provided me with a small discount for the trouble. But I think the trouble was not really caused by Batronix themselves, but by the Regal product, which in my opinion is, at least this one is not really good. So I'm very happy with Batronix. I think I will use them again because especially the support center by email was very good indeed. Anyway, talking about this unit now, so I'm not going to go a lot into the details. I found this excellent video on YouTube. It's 1 hour and 17 minutes long, and it's full of details. So we'll just leave to you to watch this video if you want to go into full details about this unit. I'm just going to give you just my impressions, why it's great for me as an hobbyist interested in HF radio and basic radio frequency. Well, it goes from 0 to 30 megahertz, so it covers all the HF radio bands. It has two outputs, and this means that you can play around with the same unit. Is basically having two generators. One can be the IF, the other can be the simulating an antenna, so the signal being received. So you can make this sort of, it's very useful to have two channels in one unit. And so yeah, it's also something I like compared to the Regal is that it has just ordinary buttons and it is very solid. Its weight, I think, 4 kilos. And so it's very simple to use. The interface does not require any, touch screen that never works properly, and so I'm very happy. You can set the output to both high impedance, so for going, for example, to an oscilloscope, or 50 ohm for going, for example, to a spectrum analyzer. And so that's great as well. And nothing, it's very simple. So you have two channels to switch between the configuration of each of them. Just a matter of pushing a button. And with another button here, I can activate, for example, channel 1. and which is now set at 100 kilohertz with a sinusoidal function. It is a matter of a second really to change the shape of the function being produced. So this is excellent. And very interesting, it can also be set to produce noise. I will talk about that a little more in a second. But okay, let's go back to sine. And I can also activate the other channel. So you can see this channel is currently set at 50 kilohertz. As you can see, the two signals are completely in phase. So they start here and they are perfectly in phase. And it's very interesting that you can control the phase. So for example, here I can put 90 degrees, and in a matter of seconds, you see we change the phase. So it's having two outputs and the possibility of combining them in terms of phase is really useful. So let me put back the phase to be 0 just for clarity. Another thing, for example, if I set, let's say, channel 2 instead of, let me see, I want to produce noise over channel 2, okay? So now channel 2, as you can see, is producing noise. It's very simple, actually, to combine the output of this unit. There is a function called wave combine, and basically I can set to output in the second port, so in the second output, the sum of channel 1 and channel 2. So basically we will get still in channel 1, I just get in channel 1, the sinusoidal signal that we get now. But in channel 2 now, here, I will get the sum of the noise and the sinusoidal wave. So let's see how it works. Right, so as you can see now, I get basically a noisy sine wave, which can be great for some testings and stuff like that. So yeah, I'm very happy. It's very simple to to disable one output, to reactivate it again, or let's say I go to let me see, if I want to, for example, parameters. So let's put back just a sinusoidal function. So I'm not sure what happened here. Yes, so I'm probably still doing something with the output setup, so let me have a look. So now channel 1 is connected to channel 1, yes, and channel 2 at the moment is outputting still, as before, the sum of channel 1 and channel 2. So this is a big sine wave plus a small sine wave. So let me put it back as it was before, okay? Anyway, what I was saying is that you can go to parameters and very quickly change, for example, the amplitude. And I can express the amplitude in terms of volts, millivolts, or dBm, which is convenient in a 50 ohm setting. So for example, let me just write minus 5 dBm. It's just a matter of a few clicks, and you see that the wave is lower. So now let me put back this to, let's say, 0 dBm. Okay, let me stop channel 2. I'm going to remove it from here. I'm going to connect it to this frequency counter. This is a very old, but I really like it. It's an HP 5381A frequency counter. It's very simple, but to measure things quickly is great. So let me just reactivate the output. And as you can see, we get our 50 kilohertz. So the two units are not connected, okay? So they are not synchronized. This Siglent has 10 megahertz output. So it's possible, for example, to synchronize this Siglent with the spectrum analyzer. Output and input, I mean, depending on how you configure things. So I could synchronize these two units. At the moment I cannot synchronize this though, because this requires a 1 megahertz time-based signal. So this can only provide through the back port 10 megahertz signal. So they are not synchronized, but anyway, as you can see, they show the same frequency. So for example, if I change the frequency again, let me put at 15 megahertz now. And yeah, now let me show the full megahertz thing. So yeah, it's very accurate in terms of frequency. I mean, this can be verified with this frequency counter in a nice way. So I'm very happy about that, and I think I will try to search for basically a frequency divider to convert the output of this Siglent send it to this unit to be completely synchronized, even if, as you can see, they basically output the same frequency. Right, so now let me disable channel 2 and also channel 1. I want to make a couple of measurements of this unit using the spectrum analyzer. So let me connect it there. All right, so let me go to channel 1, which is the channel being connected. Let me verify. Yes. So this is the cable going to the spectrum analyzer. It's currently set to 100 kilohertz. Let me put it, let's say, at 10 megahertz at 0 dBm. Okay, so let's see how it works. I'm going to start it. And there we get our signal. So let me zoom in. I'm going to put frequency, let's say 20 megahertz, and the span at, yeah, let me 30 megahertz. And here we are getting our main signal at, yeah, 0 dB. Here it says minus 0.15, which is expected due to cable losses and, you know, these type of things. And we get an harmonics here at, the first harmonics is of course at 20 megahertz. So let me see, here it is at 54 dB down, okay? The third harmonics is at 65 dB down. So let me have a look here again. 55, yes. Okay, and we can compare this with the specification. Let's see where it is. I think I had it here, yes. And so as you can see, from 0 to 10 megahertz, it says that it should be at between 60 and 50. You see, here at 10 megahertz is in between these two specifications. So let me actually put it at 5 megahertz so we can have a look at a lower frequency. So I'm going here and just write 5 megahertz. Okay, so let me change the center frequency to be, let's say, 15 megahertz. Okay, right, so peak search, we get our main signal at 5 megahertz. It says again minus 0.15, which is again the cable losses as expected. And let me make a delta measurement here. The first harmonics is of course at 10 megahertz, and it is 55 dB down. So, well, here actually the specification, let me see again, would say actually minus 60 dB down, but I guess okay, it's between minus 50 and minus 60 as you can see. So let me see if things improve a little bit linearly, reducing the frequency. So let me put a frequency of just 1 megahertz. Right. So let me reduce now the span to 5 megahertz and center frequency at let's say 3 megahertz. Okay, so I get my main signal again as expected at normal market at 1 megahertz. The first harmonics, okay, so peak search, let me take a delta marker. So the first harmonic is 60 dB down, but the third harmonic is 55 dB down. Okay, so yeah, I would say that here the characteristics, at least according to my measurement, are between 0 and 10 megahertz is probably 55 rather than 60. But anyway, so this is the measurement, at least if I understand what this datasheet is stating. My measurement show you know, harmonic distortion of minus 55 dB rather than 60 the minus 60. Anyway, I'm super happy about this product, and of course this is just a first impression, but it looks solid. The commands are very easy to interact with and very fast, and I like what I see for the moment. Oh yes, I was almost forgetting an interesting feature that I want to talk about because it can be useful to somebody, and it's about the noise generator. So if I set the channel 1 to produce noise rather than a sinusoidal function, and started at the moment, the spectrum analyzer is set from 100 kilohertz to 100 megahertz. Okay, so the span is 100 megahertz. So let me activate channel 1, and as you can see, we get a very flat noise curve here. So it's really flat from, well, let me actually activate some averaging so we can get a better view. Right, so as you can see, the marker at the moment is at here, at 30 megahertz. So from 0 to 30 megahertz, we have a very flat curve. I would say it's very flat up to 50 megahertz. It starts to go down a little bit, but it's totally usable as a pretty flat noise source up to 60 megahertz, I would say even 64, 65. So yeah, this can be very useful for those having, for example, a spectrum analyzer without a tracking generator. So the noise source can be used as an alternative source of basically a flat signal to verify filters and stuff like that. So once again, this is potentially very useful for the hobbyist in HF and ham radio stuff. So okay, this is all for this video, and I'm very happy about this unit. It's a great step up compared to the built-in super basic signal generator that I have included in my oscilloscope, and I hope I will make a greater use of it in my future experiment. So if you want to ask any questions about this unit, maybe something that I can try to verify, please feel free to leave a comment below, and that's it. Thank you very much. Bye bye.